Yes, Samya, is this audible to you?
Yes, ma'am.
Okay. So, before this, Samya, just tell me one thing. What is currently going in your physics in school? Which chapter is going or which topic is going right now?
Chapter 2 is going on.
Potential and capacitance.
Yes.
So, we have to quickly complete this chapter, no? Because in your
Yes, ma'am.
unit test also, then your this chapter and second chapter would be included. Unit tests have been covered or is it still there? It is left.
It is. It will be in June, 14th June.
14 June. Do you know the syllabus for it?
Yes, ma'am. It will be 2 chapters, and then if we complete our syllabus, we'll do the third one too.
Current
If not,
education.
yes.
Fine, fine. The June is there. No, okay.
Yes.
In 14 June.
Yes, ma'am.
So see, we had started with properties of charges. There we had seen additive nature of charge. Then we had also seen conservative nature of charge. And invariance of charge means charge is independent of the speed. The fourth property which I was mentioning you, from which the questions do come, this is quantization of charge. Quantization of charge basically means what? I have told you what is the charge contained by a single electron, Samya?
1.6 into 10 raised to minus 19.
10 to the power minus 19 Coulomb. So this is the charge carried by a single electron. Now what if I take 2 electrons with me? This will get doubled. It will be 2 into 1.6 into 10 to the power minus 19. That is 3.2 into 10 to the power minus 19 coulombs. If I take 3 electrons with me, 3 coulomb of charge, this is Q1, this is Q2, this is Q3. That becomes thrice of whatever is the electronic charge present. This becomes 4.8 into 10 to the power minus 19 coulomb. Even if I take a fourth charge, that will be 4 times the electronic charge, means 4 into 1.6 into 10 to the power minus 19. That becomes 6.4 into 10 to the power minus 19 coulombs. So are you able to notice this pattern? 1 electron, this much charge. Second electron, twice that charge only. 3 electrons, thrice that charge only. We cannot have half or negative electron, or we cannot have integral of different electron. Integer of any electron is not possible in this case. We cannot have half or decimals of electron. What can minimum electron possible is 1. More than 1 is what possible? 2 electrons. So ultimately what will happen? You can have 1 electron, 2 electron, and the electronic charge remains same. So even if this series goes on, this will become what? Q will become n times E. N is any number starting from 1, 2, 3, 4 till infinity. N can be any number. So this is the value of N, whereas E is the electronic charge. So see, the minimum possible charge on an electron is 1.6 into 10 to the power minus 19. And this means that all the observable charges that are present in nature, these are integral multiple of this only, 1.6 into 10 to the power minus 19. Whatever you have as a charge, that will be somehow a multiple of this, the way we are having these much as multiples of 1.6 into 10 to the power minus 19 only. So all observable charges integral multiple of 1.6 into 10 to the power minus 19 coulombs. Fine. So quickly note down this, then we'll do a question. How do questions come in your exam?
Yes, ma'am, done.
It says you have to calculate the number of electrons that are present in 1 coulomb of charge. So what is Q over here?
1.
1 coulomb. Perfect. And number of electrons, we don't know that, we have to calculate. An electronic charge, we already know 1.6 into 10 to the power minus 19 coulomb. So on applying this formula, Q is equal to NE. This is the first formula of your 12th standard. Q is equal to NE. Now N is missing, N will be Q divided by E. So Q is 1, electronic charge is 1.6 into 10 to the power minus 19. Now Samya, do one thing, remember this value, 6.25 into 10 to the power 18 electrons. Because most of the time, 1 by means there is a reciprocal of 1.6 into 10 to the power minus 19 would be there. So you should remember this value, 6.25 into 10 to the power 18, because then you will be saved from the calculation at the time of examination. Fine, so please note down this as well.
Done. Done, ma'am.
Done?
Yes.
Now let's begin with Coulomb's law. This was the introductory part which included this quantization as an important portion. Now see, Coulomb's law is basically what? If you have two charges, let's say Q1, Q2 are these two charges which are separated by some distance r. Then according to Coulomb's law, Coulomb's law simply states that electric force, this is directly proportional to the product of the charges. You have to consider the magnitude only. If you have -4 with you, you won't be writing it as -4. You will be writing it as +4 only. Means only 4. If you have +4, you will be writing it as 4 only. No sign is required because you take the magnitude of the charges, and whatever is the magnitude of both the charges, just multiply it. So electric force gets proportional to it. This is the first point of Coulomb's law. Second point says that whatever is the separation between them, Q1 and Q2, electric force is always inversely proportional to the square of the separation between the charges. So if the separation between the charges is small r, electric force is inversely proportional to r square. Basically, electric force is inversely proportional to Q1, Q2 by r square. Here in this, if you put a constant, this will be K Q1, Q2 divided by r square. This is what is meant by Coulomb's law. This is the formula of Coulomb's law. K Q1, Q2 divided by r square. This is what is meant by Coulomb's law. Now, let us just emphasize on what is this K that I have written, this constant K that we are using. Before moving on to the properties, you should understand what is this K. So K is 1 over 4 pi epsilon naught. Epsilon naught is what? Rest of the thing, pi, you know, 4 is already a constant number. See, regarding epsilon naught, epsilon, whenever this is written, this means absolute permittivity. This means absolute permittivity. Now, whenever I write epsilon naught, this means absolute permittivity of free space. Fine. Now, what is meant by this is that this governs the dependency of force on a certain medium. If I give you two charges which are kept in air, then F is equal to K Q1 Q2 divided by R square. Now, what if I put those two charges in water? Then Coulomb's law says that, not Coulomb's law, basically due to this absolute permittivity. Since your medium has been changed from both the charges which were kept in air, now both the charges are kept in water. Since this has changed, now your force will also be changed. And how does your force change according to the medium? This is governed by this symbol epsilon, which is known as absolute permittivity. And we put a naught for just the calculation part. Epsilon naught signifies the absolute permittivity of free space. If you have the medium as air, if you have the medium as the free space means vacuum, then you have epsilon naught. Epsilon for different mediums are different. For different media, you have different epsilon naught. See, 1 over 4 pi epsilon naught Q1 Q2 by R square is the Coulomb's law. If I change epsilon naught, then obviously F will also get changed. This will also be changed. That's why we say both of these, the dependency of the medium, this is governed by this epsilon. So absolute permittivity of free space, this is 8.85 into 10 to the power minus 12 Coulomb square per meter square. You have to remember this value. This is valid for only air or vacuum. If your medium gets changed, do not put this value. So if you write the value of K is what? 1 over 4 pi epsilon naught. So 1 over 4 is there, pi is 3.14, epsilon naught is 8.85 into 10 to the power minus 12. Now, when you will solve this, you will get the value of the constant, this K, as 9 into 10 to the power 9. This is the value of the constant, 9 into 10 to the power 9. All the units will be reciprocal, Newton meter square per Coulomb square. So in the formula, F is equal to K Q1 Q2 divided by R square. Put the value of K from here. Q1 is one charge, Q2 is another charge, R is the separation between the two charges. Is this clear?
Yes, ma'am. Ma'am, in questions for other mediums, will they give us the value and then we'll have to
You can,
calculate it?
you see, either they'll give you the value or they will give you a quantity that is known as dielectric. That we'll discuss right now. Okay, that case if some other medium is given, how will you calculate that? We'll see. We'll see. Till the time, just note it down.
Okay, ma'am. Ma'am, can you scroll? Yes, ma'am.
Okay, so before discussing that, let's discuss some properties and let's do some question that at the end of this Coulomb's law, we will see if the medium changes, how will it do. See, the first property is that Coulomb's law is valid only for point charges. For point charges or spheres, you have Coulomb's law valid. Like if the point charges are there or two spheres are kept, then you can use Coulomb's law. This is the first point. Second point of Coulomb's law says that both the charges should be at rest, or at least one of them should be at rest. Either both of them should be at rest, or at least one of the charges be at rest. This means that the distance between them should not change. For example, if Q1 and Q2 are two charges, Q1 is stationary, Q2 is moving. So still you can apply Coulomb's law, but the condition that remains the same is that this separation should not change. So this is valid when? If this is a complete circle, if this is a complete circle, the radius at each point should be smaller for Q2. This is Q1, Q2, the separation should remain the same. Or best is that if both the charges are rest, then you can use Coulomb's law. Then it is a conservative force. It means the work done is independent of the path traveled. Means work done depends on the initial position, work done depends on the final position. It doesn't depend on this way or this way. For both of them, it depends on the same initial and final position. And the second point is that it's a central force, means both the points are there, charges are there, and it acts on the line joining the two charges. Here. These are the four properties. So a very small question is there. This you first try it yourself. Do one thing. First note down these points and then try that question yourself and send me the answer. Then
Okay,
I'll
ma'am.
discuss it with you.
Ma'am, these are properties for Coulomb's law, right?
Yes, properties of Coulomb's law. When is Coulomb's law valid? What are the conditions for Coulomb's law?
Okay.
Okay, then let's discuss it. Have you converted into SI units? Because millicoulombs and millimeter, these are not the SI units. Okay, see what is the value of the force is what? Force is equal to K Q1 Q2 divided by R square. This is the formula to calculate the force. What is K over here? Yes, Samya, what is the value of K that you have used?
I did not use.
You didn't use K. See, this is the formula. K is 9 into 10 to the power 9. That's what we have studied now. Q1 is the first charge. Okay, now solve it with me. Q1, if it is 2 microcoulomb in SI unit, what will it be? See, 1 microcoulomb, this is 10 to the power 6 meters. So if I have to replace this, because see, I cannot use, I one not 1 microcoulomb. 1 microcoulomb is 10 to the power minus 6 coulomb. If it is 1 micrometer, then it is 10 to the power minus 6 meters. Whenever you have to convert micro, write 10 to the power minus 6. That makes it in SI unit form. So this will be 2 into 10 to the power minus 6 coulombs. Regarding Q2, the charge. This is, what is the charge that I should take?
-3.
-3 millicoulombs. See, this is -3 millicoulomb. But as I've told you, in case of Coulomb's law, we do not take this negative sign or positive sign because we only take the magnitude of the charges. So don't consider this minus sign. Even if it is given -3 coulomb, don't utilize it. Just write 3 millicoulombs. Now see, 1 millicoulomb, this is 10 to the power minus 3 coulombs. If it is 1 millimeter, this is 10 to the power minus 3 meters. So this becomes 3 into 10 to the power minus 3 coulombs. What will be R
3 millimeter.
in SI unit? In SI unit.
3 into 10 raised to -3.
Correct. 3 into 10 raised to power minus 3 meters. Now just put it in the formula. K is 9 into 10 to the power 9. Q1 is 2 into 10 to the power minus 6. Q2 is 3 into 10 to the power minus 3. This whole term is divided by R square. R square is also 3 into 10 to the power minus 3 two times. R into R means R square. So 1, 3, this is cancelled. This is 3. 3 into 2 is 6. So this is 6 into 10 to the power. This is 10 to the power 3. So this becomes 10 to the power 6 Newton. Clear?
Yes, ma'am.
No, just note it down. So this is how you utilize basic formulas. If you have no on Coulomb's law, right? Use constant 9 into 10 to the power 9 and convert everything into SI unit.
Done, ma'am.
Okay, Samya. There is one more question that you should try. This question. Just note this question, try it yourself, apply Coulomb's law, and just see what is your answer coming. Then I'll help you.
Okay, ma'am. Ma'am, I have done it.
So what's your answer coming?
It's 9 into 10 is 9 into 2q1 into 2q2 upon 1 upon r. Is it how we do it? I don't.
Yes. That's how we do it. See, for force first, F that you have, this is what? K Q1 Q2 divided by R square, no? This is when the charge is Q1, other charge is Q2, separation between them is R. But what is the question saying? The question is saying that the charge has been doubled, means it is 2Q1, this is 2Q2, and the separation is half, means R by 2 is there. So F prime will be what? K will be there. Instead of Q1, you will consider 2Q1. Instead of Q2, you will consider 2Q2. Divided by R square, not R square you will write square of this term, R by 2 whole square. Understood how to write this?
Yes, ma'am.
Now see, just expand this. This is what? This is 2 multiplied by 2 is 4, k q1 q2 divided by r square, and this 4 also goes. This becomes 16 k q1 q2 divided by r square. Now what is k q1 q2 divided by r square? That is the force only. So F prime is 16 times the force. This is how you will solve. Whatever conditions are given to you, just go according to it. Fine.
Ma'am, we don't have to use the value of k.
See what will happen if even if you use the value of k will get cancelled if you take the ratio of them, or you put the value of this whole term as f. Then you are not required to get the value of k. No, you are taking the ratio, so k is getting cancelled because k is common in both of them.
Okay, ma'am.
So just note it down, then we'll discuss how we'll have to solve it if we have a different medium.
Done, ma'am.
Fine, let us now see if the medium is changed, how to solve it. See, if your medium is changed, first understand, if your medium gets changed, your force will also be changed. This is Q1, this is Q2, the separation between them is R. So force in air, how do we write the force in air? As K Q1 Q2 divided by R square, or you can even write the value of K as 4 pi epsilon naught. K is what? 1 over 4 pi epsilon naught. This is R square. All right. Now, regarding the medium getting changed, Q1, Q2, R is there, and the medium gets changed. This is some other medium. This was air. Now, what will happen? You will be using force for that medium. You will have Q1, Q2 divided by 4 pi epsilon R square. Now you will not be writing epsilon naught. Reason being, this is absolute permittivity, which is required only for air or vacuum. But now if you are given this, some other medium, and you are required to use this force, then how should you use it? So what you can do, epsilon means absolute permittivity in any other medium, divided by epsilon naught means absolute permittivity in free space or air. This is equal to K only. This K is dielectric constant. This dielectric constant, when we reach potential, potential and capacitance, there we'll see in detail what is meant by this. But right now I'll tell you, right? Dielectric is whenever you have insulating material. If your medium is not air, your medium has been changed into some insulating material. Insulators are those materials which do not allow electrons to pass through them. So if you have such material, epsilon divided by epsilon naught, this is equal to K. So if you are given some other medium and you know epsilon, this can be written as K times epsilon naught. So if medium is given, just simply write 4 pi K times epsilon naught R square. Now K will be given to you. K will be 2, 3, some any other value. This will be given to you. Epsilon naught, you already know. Now will you be able to calculate the force? This will be easy now to calculate.
Yes.
Now see, if F medium is there, Q1, Q2, 4 pi epsilon naught R squared. This whole is what? This is the force in air only, no? Divided by K. So this is a shortcut that you can use. If you know the force, like I tell you the force in air is 6 Newton and the dielectric constant is 2. Simply say the force in the medium will be 3 Newtons. Directly divide whatever is the force given to you in air by the dielectric constant. Or the dielectric constant will be force in air by force in the medium. Right? This is how you use. So note this as well. Just make a note point and add this.
Ma'am, can you scroll? Yes, ma'am, there.
All right. So this was about Coulomb's law. So whatever questions will be given to you through the assignment, just practice them. That will clear your Coulomb's law. So Coulomb's law was what? Force, electric force is directly proportional to product of the magnitude of the charges and inversely proportional to the square of the distance between them. Now, electric field is your next topic. Now, just understand what is meant by electric field. See, if you have a source charge with you, source charge means that I have taken this charge, is capital Q I have taken. Capital Q I have taken. So this capital Q will be having its certain space around itself. In that space, what will happen if I bring another charge? Let's say this charge, capital Q, this is a positive charge. And this charge that I have brought, this is a positive charge. So as soon as I'll bring it near this capital Q, what will happen? This will experience a force of repulsion because like charges repel each other. Or if I bring a negative charge, as soon as I'll bring this negative charge towards this, means this plus Q, what will happen? As soon as I'll bring this plus Q towards this plus, minus Q towards plus Q, it will feel a force of attraction. Force of attraction will be felt. So see, there is a certain environment or a field around this charge in which electrical phenomena or properties can be experienced. So this charge, this remains stationary, which generates this electrical environment, and the other charge is moved to just check it, to test it. This is called as the source charge, and this is known as the test charge. Now see, this is for now this space that is around a single charge. This space around a single charge in which electrical phenomena can be experienced. Like if you have a charge plus Q with you, it is having certain space around itself. Now, if I bring another charge, I'll able to either feel repulsion if it is positive, or I'll be able to feel attraction if it is negative. So this is possible if the environment around it permits. So this space around a charge where electrical phenomena or electrical properties can be experienced, that is known as the electric field of a charge. This charge is known as the test charge. This charge is known as the source charge. So electric field is the space around a charge in which electrical properties can be experienced. Now see, electric field is what? When you are applying electric field to any material or some other material, what is happening? Both the two charges, if it is there, plus Q is there and small plus Q is there, are they actually touching each other and we are able to observe electric field, or at a certain distance we are able to observe electric field?
Distance.
At a certain distance. So what happens at a certain distance you are able to feel? It means electric field explains you the property of non-contact forces. Even without the contact being occurring between the two charges, you are able to experience that force. That is used to explain the concept of electric field. So that is only what is written to explain the non-contact forces. Concept of electric field is required. Then other thing is that when we had studied electric force, right now only when we had seen Coulomb's law, minimum requirement of charges for Coulomb's law is what? 2 charges should be there at least. If 2 basic charges are there, then Q1 is there, Q2 is there, both of them will exert force on each other. Regarding electric field, even if you have an isolated charge with you, that charge will be having the certain space around itself, the certain electric field around itself. It means this property of electric field is of a single charge. Whereas in case of Coulomb's law, you had to take or you had to consider at least 2 charges. 2 charges should be there to exert force on each other. But in case of this Coulomb's law, electric field, what is happening? Even if you have a single charge, that charge will be having its own electric field. So this is a property of a single charge. Apart from this, you should remember that electric field is a vector quantity. Electric field is a vector quantity means it will be having its direction, it will be having its magnitude. See, scalar quantities and vector quantities are what? Scalar quantities are those quantities that do not, they are just having their magnitude. They do not require any direction to specify them. Vector quantities are those quantities that have the magnitude as well as they have the direction with them. So electric field is what? It's a vector quantity. It means you require the utilization of vector laws for its solving, or for the finding out the direction, vector is required. So the concept of vector is required. So are you able to recall your vectors, parallelogram law and everything? Or you require some revision class on that? Just let me know.
Once revision
required. No. So okay, in the next class then we'll first quickly revise vectors. That will help you, because in electric field what will happen? Even in electric field and electric forces, direction will be there continuously. One vector will be here, other vector will be here, angle between them will be somewhat. Then resultant you have to calculate. So resultant without the usage of vectors won't be able to, or you won't be able to solve it or calculate it. Or you can do one more thing. If you are available tomorrow, then I have a class on vectors only. So if you wish, you can join that. Otherwise, you can continue in your normal class.
Yes, ma'am. I'm free tomorrow.
Tomorrow you are available?
Yes, ma'am. At what time?
You are in which country?
I'm in KSA, Saudi Arabia.
Saudi Arabia. So 4 to 5. You're 4 to 5.
Okay, ma'am.
Okay. So there I'll be discussing the basic of 11th only, vectors. I'll be doing vectors only. So you can join that class. So then you can easily cover this, your
Okay.
question. And one more property of electric field. This is that electric field travels with the speed of light. It means the speed of light is what? 3 into 10 to the power 8 meter per second. So this is the speed with which electric field lines travel. Electric field lines travel with the speed of electric field travels with the speed of light, that is 3 into 10 to the power 8 meter per second. So this is the introduction of electric field. What is the formula of electric field? That we will see in the next class when you have it on Tuesday. But before that, vectors is required. Otherwise, it will be very difficult. So just note it down, and then tomorrow, please try to join the class if it's possible for you. I think it would be helpful for you.
Yes, ma'am. Ma'am, can you scroll? Done, ma'am.
All right, fine, Samya. Then let's continue in the next class, and tomorrow